just in case. Okay, so good morning, everyone. Just to review the last lesson quickly, or the last lessons. In general, we said in Python we have data types, and these data types are, let's say, 5 data types, which is the integer, float, string, and Boolean, and none, which is the special type of Python. Right, Lizon? Because you are the only one in here, so. Okay, so these are the, let's say, the basic data type. Now, when we are going to talk about the compound data type, we have 4 types. So we have the tuple, we have list, we have dictionary, and we have set. Okay, this is how I make like mix of these data type. So tuple, like what? I'll give you here the example. Tuples, like saying A is equal, and I use this parentheses, the normal one, and I said 2, let's say AB, and minus 3, 2.5. So this is tuple. Okay, and tuple, it's immutable, so I cannot change the values of the any member of that tuple. That's why we call it that safe programming. List, it's exactly like tuple, but it's immutable, so I can't change the values inside. So I can use the same thing. See here, it's 2 AB minus 3, 2.5, but I use the square brackets. Okay. Now, when I'm coming to the position, this is the position, the index or the position is 0, 1, 2, 3. Just to remind you about what you do. This is 0, 1, 2, 3. So we have to start from 0. Now, in tuple and list, the problem is that the computer or the programming language or these things put these things in order, and you have to save this in your mind, the order, and then you have to think deeply about how you can use it in programming. So this is very important to know, that when you are using tuple and list, you have to be very careful about the order. Why? Because if you wanted to get, let's say, AB, you have to say here print, and I will take the tuple name, which is A, and it said AB. You see, this is 0, this is 1 position, so I have to put 1 in here. In this case, the AB will be print. You get the idea? Now, if you wanted to print the same AB from the list, it's the same. So I will say print here. You can say this is print A. You can say comma print B at 1. The only difference between tuples and list is immutable, and they have like side effects, so it's not easy to deal with the lists. So if you print A1 or B1, you will get the same result. Why? Because the same order, okay, same index, but the idea of immutable and non-immutable one. Okay, now if we are going to see the dictionary, as long as this is here, See, this is the position 0, position 1, position 2, position 3, or the index 1, 2, always started from 0 when we are going to do the index. If I wanted to make the same thing with dictionary, that I love about it, that programming language, it is not going to put the, I leave it like this so you can see it better. Programming language, it's not going to put these indexes for me. I will put it by myself. So I will introduce the dictionary by myself. So what I am going to do now, I will do the same, exactly the same dictionary, exactly the same values. So when I say, I will introduce dictionary like C, and I will say, if I say C1, it will print the same value. So what to do? So I will say C is equal. In dictionary, I use the curly brackets. So these are the curly brackets. And then what I am going to do, this is position, the index 0, it's going to 2, right? So I will say position 0 is referring to 2. Exactly like the list and the tuple. Position 1 is referring to AB. Position 2 is referring to -3. Position 3 is referring to 2.5. Please write this and these things. So now when you are doing the print, you will get the same answer from the 3. Now, what's the benefit of dictionary? First of all, it's immutable. It's look like a list, but the idea that when you put the index by yourself, you will remember that index. And in many programming purposes, I need to introduce that index by myself, but you have to remember in dictionary, you have to get like unique index. So you cannot do the index 2 times. So if you put the same index, you wanted to add, let's say, member to the dictionary, and you want to put the same index, so that it will cancel the old value and bring the new value. And this is some side effect of the dictionaries. I will write the dictionary in different way with the same value, but I will name it like different things. So I will say D is equal. And I wanted to give dictionaries in my definition. So I will use the same number, okay, but different indexing. So I will say here, let's say here Z, it's referring to 2. Here maybe I'll say another tuple like 5, 1 is referring to AB. And I will say maybe B zone is referring to -3. And then I will say 10 is referring to 2.5. So it's the same values, but I changed the indexing. So if I wanted to get the same result, which is the AB, so I have to refer to the index of that AB. So I will say print, if I want to get the AB from D. So what's the index of the AB? Is 5 and 1, tuple 5, 1. So I will say D, and I will put this. And what I will put here inside this, I will put the index, which is here in this case 5, 1. So So you see, even the key, you can use it as a tuple, can use it in the data type, but it should be unique, it should be immutable. So you can use string, you can use Boolean, you can use float, you can use integer, and you can use tuple. And you can use your name, because actually your name, it's a tuple one. So these are the tuple list dictionaries. Now what about sets? Sets, we can introduce it like what? Like let's say E, if I wanted to make the same values of sets, so you will do like this. So we'll say 2 AB minus 3 and 2.5. So set, it's like a basket. There's no order for it. It's like a basket that you put these numbers. So the difference between sets and dictionaries is the colon. See the colon in here? So in dictionaries, you have to get like 2 members in, or 2 things in each member. Here you have only like 1 member, but the only difference that use the curly bracket in sets. Any questions so far? Nick? Any question? Okay. Great. So please try to apply this. Okay. And at the end here, you put E in here. Just put it in here, in this position, and say print. If I wanted to print the all of them, so you can say print A, comma B, comma C, comma D, comma E. So you can see all these type, and this is what we call the compound data set or data types. If you wanted to know about any data type, you can use the same one in here, print A, B, C, D, E. You can just say here, let's say if you wanted to see what's the type of C, so you can say print, comma, and then make type, let's say, of D. So in this case, this will tell you what type of data type you have. Any question so far? It's working with you? Let's see. Yeah. What is the result? What's this? It's works, right? When I use the programs. Okay, okay. But I wanted to see if this is working or not. Go to the programmers and then copy it to Word. It's better. So just copy it from here. Oh. Just oh. Okay. Yeah. So try to make it so that yeah, A, B, C. because I want you to send it to the group, yeah? So everyone can take benefits from it. Nick, if you can write these things as well and tell me the result on program is. So put the make it small, make it small is better, make it small. All of them make it small. In Python we use small always. Okay, and change it this is okay. Yeah, A, B, C, and put A up. It's better A, B, C, or just take C. It's all small. Take A at the beginning. Yeah. Yeah. Yeah, great. Yeah, just to arrange it. So you have tuple, list, and then dictionary, right? So if you run, okay, as expected, this is dot or comma. Is this in C? This is in A. So what's the problem? Okay. Okay, copy it, all of them. Say, no, all of them, all of them. Okay, Control X, refresh. Yeah, run it. What's the problem? Run it again. Let me try it myself. Okay, like this. Yeah, yeah, you're right. They consider it like, yes, you're right. They consider it. Okay, so. Yeah, great. Great. So this is 2, yeah, that's fine. That's fine. And then go with the D, and then E. D. So copy the same, but just change the indexes. So copy it. Yeah, yeah. Okay. Yeah. Yeah, copy it. Okay. 2, and then 2.5, 5, 1, 5, 1, 5, come on. Okay, and then 80, colon 80. Yeah. And comma, reason, name. Yeah, reason. Okay. Colon -3, -3, and then 10, 2.5. 2.5. Make all of them this A1111. So we can compare this one, this one, and then print D of 5.1. Yeah. Print D. Yeah. Open the brackets, close the brackets. D should be square. Careful. Always indexing square. Okay. 5.1 should be triple. See. 5. Come on. Okay, and then see it's the same result, so everything is fine. Now go and put E under D. E is equal 2AB minus 3, 5. So it's the same, just change the brackets. Just copy this one. Yeah, copy this. And put the curly brackets. That's it. Okay. Okay. And then set print type print A, B, C, D, E. This is print A, B, C, D, E. Yeah. Print A, comma, B, comma, C, E, and then type D. Type D to know what's the one. Okay, great. Now type print again. Just copy this, the last one. Copy it, all of them. Okay, copy it. Type E. So the result. So you see here how you find the types. Okay, so if you wanted to know any of them, you can use the types. So if you can send this to the group, please, so we can share it with the others as well. No, just copy and paste. Copy the whole code and paste it to the group. Great. Yeah. So Nick, now you have the code with you, right? So you can apply the code and you can see the result. Now I'll go to the presentation, share it with you. Okay, and try to apply it with me. So I'll go here, share. Okay, share this. So now my screen is in front of you, right? Please on. Yeah, great. So let's go to the data presentation. Not data presentation, it's Google Drive. And designing. Okay. So we finished, I think, last week. Let's see what we finished. We finished the week 3 and asking you to prepare week 4, which is object-oriented programming. So we'll go to the week 4. Okay. So here, week 4. So actually we will go with this introduction to object-oriented programming and EDP, okay, explanation of object-oriented programming and event-driven programming, and then we'll go with the rest of the lecture in the application. So these are our sections. Explain the basic concepts of object-oriented programming, understanding the benefits of using object-oriented programming in Python, implement object-oriented programming in Python, and explain the basic concepts of event-driven programming, and. This subject is so big. What I need from you is to go with these slides like on your self-study in details, because I cannot cover these things in one lesson or two lessons in even 3 lessons. So you need to go by yourself on these things. So what's the object-oriented programming? Paradigms that use objects to present real-world entities and their behavior. So in general, what we have, actually, what we explain in the beginning, we start with the data type like integer, float, string, boolean, and none, right? And then we develop it to make like a compound data sets. So we have like a tuple, list, dictionary, and sets. Now, when we are going to be more in this, Lizon, can you see my video, right? So you can see the board, right? Okay. So in general, I will go with the things that I want you to write it, to know how to go with the object-oriented programming and to understand what's the object-oriented programming. So if I am going here and I wanted to start with, before going to the object-oriented programming, it's all related how I organize the program to solve a problem. Normally, any problem in the world, I can divide it or decompose these problems to smaller problems until my problem will be like I decompose until I find each problem it's easy to solve. So I start solve these small problems and connect it to each other, going to solve the bigger and bigger and bigger, and then I solve the whole problem. So this is where we are going to use what we call, so all the things that we did it in programming is related to the organization, how you organize your solution. Because your project is IT solution, so we have to get like some problem and try to solve that problem. So we need to organize that things. So this is like the object-oriented programming and the event-driven programming is coming because of that. So what I am going to do now, first we need to introduce the functions. So I will go here and see how we can introduce the function. So I can say if I wanted to add 2 numbers, how I do it in function. To do these things, I need to use the keyword def. So I will use, now I'm going to define the function and then going to tell you about the object-oriented programming. So please write it with me on programmers. We said def, okay? And then I wanted to introduce like the add function. So I will say this is add underscore function, func, let's say. And then I will put like x, y. And then I will put this. X, y. And then I will put this. The colon. Should put the colon. When I make enter, I will get the indentation. So I will have like a space in here. So I can put my things. So first of all, I wanted to tell the user what this function is doing. And this is what we call the doc string. So I will make like this. or we'll make, sorry, 3 quotations. Okay, make enter, and make another 3 quotations, like 1 space in here. And here what you are going to write, here you are going to write the help of that function, what this function do. So I will write, okay, it's adding function. You can write it in normal English, adding function. Okay, required input X and Y. Okay, and output the Z, which is equal X plus Y. Okay, and then I will give the instruction, the data type should be identical, and then I put, this is what I wrote between these quotations. So this is all indentations here. This is the indentation, this is the same indentation, same indentation, same indentation, same indentation. These are, we call this one from here to here, we call it like doc string of the function, like what this function going to do. Okay, we call it docs function, and this is recommended. Now I'm going to write the function. So when I'm going to write the function, I have like X and Y. So I will say Z is equal X plus Y. So this is my function. What I wanted to return, I wanted to return the value of Z. So I will say return Z. So actually what this doing, this one, the Z in here, and here also I have the indentation, careful, I have the same indentation in here, and I have, when I said return, this is the end of the function. Okay, so in general, here represent the processing of the function, and here it's represent the return value. Now keep in mind, if I am not saying return, it's acceptable in Python, but they return none type. You know, when you have like types like Boolean, integer, string, float, and we have the none type. So if you are cancel this step, it will return none. Okay. So now I define the function, but I did not call it. Like I prepare something, but I did not use it. How I can use it? I can use it by call it. So if I said result, and here you have to come from the beginning, okay? And if I said result, you see there is no indentation in here because I finished. That one is related, this indentation related to the function. Now I'm going to, so if I said result is equal, and I call that function, and I said add function, this is underscore, by the way, it's not dash, it's all underscore. Okay, and I said 3 and 4. So in this case, I call the function here, I call the function. I am calling the function now. I wanted to see the value, 3 and 4 should be give me like 7. So I will say print print results. Print result. And please check the answer. Is it working with you? Zoom? 7? Great. Now, if I wanted to make something else, and I will say here, this called the function 3 and 4, and then I said, let's say text is equal add function, add underscore function, func, and I will say, I'll put my name, so I will say Athir as a text, and then comma, and Mahr. And close this one. Okay, and then I said print here, print result as before, and comma text, and see the result. You can put your name if you like. Yeah, result and text element. Yeah, the text say, yeah, great. So now it's working. So this is how we are define the function and how to call the function. Okay, I can put it directly in the print if you want, like print add func 1 2. So it will go with the result of 3. So this is how we are developing the idea. Now, why I am using function? Because sometimes I need to repeat some codes many times, okay? Or I need to organize my code. So it's better to put it like functions. So this is the add function, this is subtract function, this is the factorial function, this is this function doing this for this function. So each function actually will solve some small problem of my program. And when I wanted to go with that problem, I just call that function and it's coming out with the result. Now, these are for the functions. So what about the these things, like the object-oriented programming and the other things? So object-oriented programming, as we have before the data type, like we have the basic data type, and then we have the compound data type. It's the type of organization, like how to organize your code. And then we define the functions where we organize more the code. But we see that this is not enough. Sometimes when I solve a problem, when I divide it to the smaller problem and smaller problem, I see that these smaller problems, it's going under the category, one category. And this is, we call it like a class. So I will say, oh, these data and these functions that processing these data, it's belong that thing. So that thing means that object, that target. So we call it like object in this case. And this is the idea of object-oriented programming. It's all about how to organize your code. So what the class have the data and have the functions that processing those data. Like human being, we have like properties like the height, the weight, these things, this data. And we have actions. like walking, seeing, viewing, reading, is all actions. So actions mean functions, and the other things is mean data. So any object in the world has these two things, data and functions. That's why we call it use the object-oriented programming. Event-driven programming is a special case of object-oriented programming, which is go more deeper in organization or in how to interact with the users. So any windows with the clicks, with the buttons, with the mouse click, with these things, we call it object-oriented programming. Now, when we are using our mouse and click on the button, what will happen? This button is connected to the a function. And when you click on that button, this function is triggered and working, like saving file, doing this, doing that, anything related to any action, we call it event-driven programming. So the details in here in the slides, okay? So in general, object-oriented programming paradigms use the objects to present real-world entities and their behavior. Key concepts of this, classes, objects, attributes, methods, inherence, and polymorphism. So this is, if you see these concepts, like key concept, classes, object, attributes, methods, inherence, and polymorphism, it's all related how you are organize your code. So it's look like we started with something simple, then we are going to organize it more, and then professional organizing, where we are reaching the inherent and polymorphism. Now, do we need to know these things? Yes, we need to know these things, but not that deep or that things. We just need what we needed to build our solution later. Benefits. Code reuse, so I can reuse it again. Encapsulation, abstraction, and modularity. Okay, how I put my code in modules. Event-driven programming is the programming paradigms that it's based on event and the handling of the event. The key concepts: event, handler, and event loop. So actually here, now when I am on this presentation, I use the arrows to go from this slide to this slide, let's say, right? Actually, this is event-driven programming because my program waiting for me to press some key so it can respond, okay? So this presentation is event-driven programming because it's depending on my action. So key concepts, event handler and event loops, the benefit: responsiveness, scalability, and modularity. So the most important things is responsiveness and scalability, and this is where the user love more. Or our mobiles nowadays is event-driven programming, because when you are going to do anything in your mobile, actually you are touching the screen. So touching the screen is the event, okay? Going with the buttons, open apps, doing this, doing that, it's all event-driven programming. So how we define the class? As I said, the class, when we have data and we have functions related to those data, we can put it in one category. So it's look like I have like 100 function and 1,000 data, but I know each collection of data and collection of these functions, I can categorize to, let's say, 4 categories or 6 categories, or maybe 2 categories, or maybe 1 category. Okay, so it's better to organize it more, and organize it more category, we call it like class. So when I am talking about the dog, let's say, so you see here class dog here, and you can see that these are the data for the dog: bread, name, and color, because each dog can have these things. So I just put, so I said dog one you saw is equal dog and open bracket close bracket. So this is how I define the class, which is define the category. Let's say define the basket that I will put all data and functions in it. Okay, so I will say class and then the name. Okay, and in Python, when we have a class, we use the first letter as a capital letter, just to distinguish between the class and the normal data. So class dog, and I put these values. So only values here I put, only data I put it, and this is what we call it in class concept. We call it attributes. So attributes actually is the data, and methods in the class we call it functions. Oh, sorry, functions in the class we call it methods. So here, as you see here, class dog, bread, I have only data in here. And then how I can make instant. What's the meaning of instant? I have like millions of dogs, but they are all share these data, like bread, name, and color. They have these things. So I will say dog one, dog two, dog three, dog million. Okay, so I don't need to, create new data and it's there. So when I said dog one is equal dog and then open bracket, close bracket, mean this is taking the properties of this class, of that category. So I know that my category is dog. So I will say dog one is equal dog, dog two is equal dog. So they are it's look like I am introducing the new type. So I said the dog one is the type dog, the dog two is the type dog. Okay, so there are two dogs. Okay, and then I will now give data for the dog one and dog two. So dog one breed is this, dog one name is this, dog one color is this, while dog two breed is this, dog name is this, and dog color is this. So the class is a blueprint of creating objects. A class defines a set of attributes and methods that an object will have. Object, an instant of a class. So this is the class, and these are the dog one and dog two objects. Okay, so it's the class is the blueprint of the object. So I put the blueprint first, and then I said I have this object, and this object. Attributes and methods in classes. Attribute is the property of an object that stores data. So as I said, data in classes, we call it what? We call it attributes. Okay, or properties sometimes we call it. So attributes is the data of the class, while methods is what? Is functions. Functions associated with an object and perform this. So we have this class and the class dog, and then now I develop this one. So you see it's the same class dog, and then I define a function, and this function is called bark. And I use always self because this is related to the same class. So maybe you are confusing with self. It's not an easy concept, by the way, but keep it like this. When you are defining any function, you have to put self in the beginning. Okay, and then print. Now how many parameters in here I have? I don't have any parameters because self is not a parameter. Okay, so I say define park and print park, just printing this. And then I said dog one is equal dog, so dog one dot park. When I wanted to call that one, I said dog one dot park, and the output will be park. You need to write this code to understand it better. Okay, as I said, you need to work on this and try to understand the object-oriented programming, because this lesson will not be enough for that thing. Inherent class. Now, if I have a category and I wanted to make like a subcategory of that one, so no need to write the original category again and again. This is what we call the inherence property of classes. So I have class animal, and in animal I have species, and I have make sounds. So I have data and I have function on that animal. When I'm going to derive these things, I don't want to repeat species and repeat this thing again. I will say class dog, and between the brackets, I will put animal. So in this case, all properties of this class is coming inside this class. So no need to repeat this because it's already there when I said class dog animal. So this is the parent and this is the son. So animal is the parent class, dog is the son class. So now I add breed name, color, and then define park is the same thing. So now when I wanted to call the sound in here, I said dog1 is equal dog, but I said dog.make sound. Now make sound is not here in the class, but actually in the parent class. As I said, when you are inherent something, so it's look like you put all of this in here inside. So what you are going to do, dot mark, so you don't need to say animal dot this. It's clear. When you said dog1, it's taking the all properties or all attributes in here, plus this attribute, and you have two functions now, this function and this function. It's look like these things, I copy it and put it here. Is that clear? Now, dog1 is equal dog, and then dog1 dot make sound, okay, output sound, okay, and dog1 dot park, it's output park. So this is how we use the inherence in object-oriented programming. Now let's say you are deriving this. I mean, you put this function. You take this data and this function, but here you came back and you define this function again inside this. So if you define the function inside the son class, it will take the son class function. So it will not take the parent class. Only if you are not override that function in son class, so everything is fine. So this is the beauty of inherent. Now, polymorphism in classes. Polymorphism is a mechanism that allows objects of different classes to respond to the same method call in different way. So it's all related to the organization. So I said class animal, class dog animal, and they said, and then class cat animal. Because dog and cat, they are animal, right? So I am using the same thing, and here I have the same, almost the same values. So when you are going to the sound, it's going to meow, meow. This is the cat of that one, okay? Now, you see here, when you make dog1 is equal dog and dog1 dot make sound, it will give you the park different, while the cat1 is equal cat. When you are making cat1 dot make sound, it will go with the meow meow. So it's all about how to organize your code. Event-driven programming, as I said, event-driven programming is a special case of object-oriented programming where the object is there. So when you are using these things and use Replit in here, the program is not enough for that. So you have to go to Replit and use it to write these codes. Definition of event and handler. Event is a change in a state of a program. Like when you are pressing the button, you are changing the case of that button. Before is unpressed, and now when you press on it, when you click on it, you are pressed. So it's look like true and false of that button. So if it's true, it will do something. If it's false, doing something else. Handler is the function that handles an event and perform specific action. So handler will take that action, like when you are pressing on button, actually the handler said, oh, this is now true. So it will take this action to the function related. So what's connect that button with that function, we call the handler, okay, to perform the things. So you can see, you can compare these two codes. Event loops in object-oriented programming, and this is the loop that can continuously check for event and calls the appropriate handler. This is where you are going to actually in event-driven programming. They're always checking: is there any click? Is there any mouse click? Is there any keyboard press? Is there any, let's say if this is depending on the camera, is there anything happens in the view? Is there any? So there's a program is going and checking again and again and again, and this is one of the properties of event-driven programming, because they have to check these things in loop. Okay, so this is like infinite loop until you kill that program. Like any application in your mobile, any application in your mobile, they are waiting you for make action. So actually it's a loop, checking and checking and checking every millisecond maybe, or every second, depending. Benefit of event-driven programming: responsive, scalability, and the modularity. So the first one, the ability of the program to respond immediately to the user. Scalability is the ability of the program to handle increased workload and event. And modularity is breaking down a complex problem into smaller, more manageable parts. And this is we call the in problem solving, called decomposition. Okay. So please go to this slides. We finish the things. If you can, please give me your opinion about the lecture today. I know it's a lot, but you need to go and practice and make like self-study of object-oriented programming and event-driven programming, because I know that this lecture will be huge for you. So you need to go and make like self-study for this one to start the project from the next lecture, and we'll choose a project to work on together. So please be in class face-to-face is better than doing the recording. Any question? Lizon? Nick, any question? Okay, so please just fill this form for me. I'll send it to the group. Where is the group? Yeah. So this fill this for me, please. And thank you for attending this lecture. See you next week.